In today's lesson, we are going to dive into scientific notation. Welcome back to my channel, Numerics with Nadia, and let's get into our lesson overview for today. So this lesson will teach you guys everything you need to know about scientific notation. Scientific notation is a way of expressing very large or very small numbers using powers of 10. So our lesson objectives for today, by the end of this lesson, you guys should be able to understand the purpose and structure of scientific notation, convert numbers between standard form and scientific notation. We're also going to go over how to perform mathematical operations, so addition, subtraction, multiplication, and division using scientific notation. And then we'll also touch on some real-world scenarios where scientific notation is widely used. And now that we've gone over our lesson objectives, let's get into a few key definitions. So first off, what is scientific notation? As I already mentioned, scientific notation is a way of writing very large or very small numbers using a base number, which here we have as A. And this base number needs to be between 1 and 10. And then, so we have the base, and the other component of scientific notation is that it is multiplied by a power of 10. So our general format is A times 10 to the n, where A is a decimal number between 1 and 10, and n is an integer representing the exponent, which indicates how many places the decimal has moved. So if we have a positive exponent, n would be greater than 0, and that means that the number is large. If we have a negative exponent, which would be where n is less than 0, that would indicate that the number is very, very small. So that goes over scientific notation. Now for standard form refers to writing numbers in their usual numerical representation without exponents. So an example of a large number in standard form would be shown here as 5,600,000, and we also have an example of a small number in standard form. So now that we've gone through the key definitions, let's go through some real-life applications of scientific notation. This can be used in astronomy, for example, expressing distances in space. We can see it used in medicine, for example, representing the sizes of a microscopic organism. We can see it in finance, representing national debt of a country in trillions of dollars, and also in engineering, for example, measuring circuit components or storage capacity. So these are the real-life applications of scientific notation. And now let's get into how to convert between standard form and scientific notation. So for number 1, it says we are going to be converting from standard form to scientific notation. We are given 4,750,000, and we want to convert this to scientific notation. So we're going to do 4 simple steps here. First, we're going to identify the decimal point. Then we're going to move the decimal left until only one digit remains in front of the decimal point. Then we'll go through and count the number of spaces that we moved our decimal point. And finally, we will just rewrite it in scientific notation. So here we are given 4,750,000. The decimal place currently is at the end of that last 0. So I will mark step 1 in red. We can see where our decimal point currently is. Now in blue, I'm moving our decimal to the left until only one digit remains in the front. So now let's count those places. We have moved the decimal 6 spaces. So now let's put everything together. We moved it 6 places, and what's the decimal point we ended up with? We ended up with 4.75 times 10, and the power of the 10 is the number of places we moved, so it'll be 4.75 times 10 to the 6th. That is our answer for our first example. Now for example 2, we are converting from scientific notation to standard form. So kind of the opposite of what we just did. Here we're given our decimal, so we're going to write our 3.2, and here we have times 10 to the negative 4. So that means we're moving our decimal 4 places to the left. And when I do that, I end up getting my answer of 0.00032. And one important note here, when you're converting scientific notation to standard form, we always have to pay close attention to the exponent. Here in our example, it was negative, so we moved left. If, and in an example, it is positive, that just means that you would move right. So that's an important distinction. And now that we've gone over how to convert between the two forms, let's get into some step-by-step examples for the different operations. So for our first example, we have multiplication using scientific notation. And our example is 3.2 times 10 to the fourth times 2.5 times 10 squared. So we're just going to follow two simple steps here. First off, we're going to multiply the coefficients, and then we're going to add the exponents, and then we put our answer together. So for multiplying the coefficients, our coefficients here are 3.2 times 2.5. When we do that, we end up getting 8.0. And then our exponents, I'm circling here in purple, we have 4 and 2. So we're going to go ahead and add those exponents. 4 plus 2 gives us 6. So our final answer is just 8.0 times 10 to the 6th. Next, we'll get into doing division using scientific notations. The steps are pretty much the exact same, except instead of multiplying, we're going to divide, and instead of adding, we're going to subtract. We have 6.4 times 10 to the 7th divided by 2.0 times 10 cubed. So our coefficients here are 6.4 and 2.0. We're going to divide these coefficients. When we do that, we end up getting 3.2. And then looking at our exponents, we have 7 and 3. And since we're dividing, we're going to subtract the exponents. 7 minus 3 gives us 4. So our final answer is 3.2 times 10 to the 4. And now we'll get into adding using scientific notation. A really quick and key point here. To add numbers in scientific notation, the exponents must already be the same. So here we have 4.5 times 10 to the 5th plus 3.2 times 10 to the 5th. In this example, our exponents are the same. So we can just go ahead and follow two simple steps. We're going to add the coefficients and then keep the exponents the same. There is a situation where we won't have the same exponents, and what we'll have to do is we'll have to rewrite them. We're going to go ahead and cover this in a later video, but for now we'll just solve it as is because the exponents are the same. Looking at our coefficients, we have 4.5 and 3.2. 4.5 plus 3.2 gives us 7.7. Now looking at our exponents are 5. So our final answer will just be 7.7 times 10 to the 5th. And now we'll get into our last section, subtracting using scientific notation. The same rule applies that we used for adding. The exponents must already be the same in order to add or subtract them. For subtracting, the steps are the same. Instead of adding the coefficients, we're just going to subtract the coefficients and keep the exponent the same. So here we have 6.2 times 10 to the 6th minus 1.5 times 10 to the 6th. Our coefficients here are 6.2 and 1.5. We're going to go ahead and subtract them. 6.2 minus 1.5 gives us 4.7. And then our exponents here are 6, so that's just going to stay the same. And that will make our final answer 4.7 times 10 to the 6th. And that wraps up our video for today. Thank you guys so much for watching. I hope you enjoyed the video. Please like it if you did, comment any questions or any other video topics you would like to see down below. Please subscribe if you haven't already. Share this video with a friend, and I will see you guys next time.